Hello dear students. I hope you all are well at your homes and enthusiastic about your studies. Children, today we are going to study the chapter 3 of class 10th science, that is metals and non-metals. So let's see what we have learned earlier. On the basis of their properties, elements are divided into metals and non-metals. Metals and non-metals are different with each other. Do their properties are different from each other? Or metals and non-metals react with each other, or air, water or acid? Now let's see what we are going to study in this chapter. How metals and non-metals are different from each other. Physical and chemical properties of metals. What will be the effect of air and water on the iron nail? Extraction of metals and their refining. Activity series. How metals and non-metals reacts with each other. Properties of ironing compound. Corrosion and its prevention. So students, let's start with the physical properties of metals. All metals are generally solid at room temperature. For example, iron, lead, zinc, copper, etc. But there is one exception to it, that is mercury, which occurs in liquid state at room temperature. Metals are good conductors of heat. For example, silver and copper. But lead and mercury are comparatively poor conductors of heat. Metals are good conductors of electricity. That is why electric wires are made up of metals. For example, wires made up of copper and aluminium. But you must have seen that the current carrying wires have a coating of polyvinyl chloride, that is PVC, or rubber-like material, so that we do not get electric shock when we touch them. Metals can be beaten into thin sheets. This property of metals, by which they can be hammered into thin sheets, is called malleability. The gold and silver are the most malleable metals. Metals can be drawn into thin wires. This property of metals, by which they can be drawn into thin wires, are called its ductility. Gold is the most ductile metal. Metals are generally hard. For example, iron, copper, aluminium, etc. But again, there are some exceptions to this. Hardness is not same for all metals. Some metals like sodium and potassium are very soft. We can even cut them with the help of a knife. So hardness varies from metal to metal. Students, you might have seen any new metal like iron, gold, silver, copper, aluminium, etc. They have shiny surfaces. All metals in their pure state have a luster, which means that metal have shine or brightness. This is called metallic luster. Metals can produce a specific sound on striking with any hard object. So they are sonorous. For example, you must have heard the sound of your school bell or sound of bells in temple. They all are made up of metals. Metals have high melting and boiling points. For example, melting point of iron is 1535 degrees Celsius and boiling point is 2750 degrees Celsius. Metals have high densities. That is why they are heavy substances. For example, iron density is 7.874 gram per centimeter cube. Other metals like gold, silver, iron, etc. have high densities. But sodium and potassium metals have comparatively less density. Lithium metal is the lightest metal because its density is very less. Dear students, now we will study the physical properties of nonmetals. Nonmetals generally exist in solid or gaseous state. For example, sulfur. It is a solid nonmetal, and oxygen, nitrogen, etc. are gaseous nonmetal. But there is an exception to it, that is bromine, which occurs in liquid state at room temperature. Nonmetals are poor conductors of heat and electricity. But graphite, which is an allotrope of carbon, is the only nonmetal which is good conductor of electricity. Non-metals are soft and brittle in nature. That is why they can be broken into pieces on applying pressure. For example, coal, which is a form of carbon. Non-metals cannot be drawn into sheets and wires. It means they are non-malleable and non-ductile. Non-metals are soft, for example, sulfur. But again, diamond, which is a allotrope of carbon, is the hardest natural substance known. Nonmetals also do not have any luster. For example, sulfur, but iodine and diamond, they are the exceptions. They have lustrous surfaces. Non-metals are non-sonorous. They do not produce any specific sound when they hit with a hard substance. Non-metals have low melting and boiling points. For example, melting point of sulfur is 115.2 degrees Celsius and boiling point is 444.6 degrees Celsius. But diamond, which is an allotrope of carbon, has a very high melting and boiling point. Its melting point is 3547 degrees Celsius and boiling point is 4827 degrees Celsius. Non-metals have low densities. That is why they are light. Dear students, now we will discuss about the chemical properties of metals. Metals react with oxygen, water, air and acids. Iron develops rust on its surface when it remains in contact with atmospheric oxygen and moisture. It means it converts into its oxide. When we burn magnesium ribbon, it converts into magnesium oxide. And when the ashes of magnesium oxide is dissolved in water, it forms magnesium hydroxide. This reaction occurs in this way. Magnesium plus oxygen gives magnesium oxide, that is 2MgO. This magnesium oxide MgO plus water H2O gives MgOH post of 2 magnesium hydroxide. To check the nature of magnesium hydroxide, that it is acidic or basic, we perform litmus paper test. We see that in this solution of magnesium hydroxide, red litmus paper changes to blue. It shows that metals react with oxygen and form basic oxides. Now, let's see the reaction of metals with water. Metals, when react with water, form basic oxides, and heat is also produced. Students, let's perform an activity to understand this. Take a beaker of 250 ml. Fill it half with cold water. Now, carefully cut a small piece of sodium metal. Make it dry with the help of filter paper, and now place it in a piece of cotton and put it in the beaker half filled with cold water. Children, you have observed that sodium reacts violently with cold water and it immediately catches fire. Now, if you touch the beaker, you will feel that the beaker is warm. If we test this solution for its acidic or basic nature with the help of litmus paper, we observe that red litmus paper changes to blue. It shows the basic nature of this solution. It means metals reacts with water and form basic oxides. Children, you have observed that sodium reacts violently with water. That is why it is kept in kerosene oil. But, dear students, we should remember that all the metals, they do not react vigorously with water like sodium. Another metals like lead, copper, gold, silver, they do not react with water at all. Reaction of metals with acids. Metal reacts with acids and produce hydrogen gas. Let's understand this with an activity. Take 5 milliliter dilute sulfuric acid in a test tube. Take 20 milliliter of soap solution in a beaker. Now put some zinc granules in test tube. We observe that reaction started in test tube and some bubbles are formed. Now pass these bubbles to the soap solution with the help of a delivery tube. Now take a burning matchstick on the bubbles coming from soap solution. We will see that a popping sound occurs when the gas present in soap bubbles come in contact with burning matchstick. This shows the presence of hydrogen gas. Now let's see the reaction of metals with bases. Metals react with bases to form hydrogen gas and release heat. Let's observe it with an activity. Take a test tube and make fresh solution of sodium hydroxide. To make it, we can add 4 to 5 pellets of sodium hydroxide in 5 milliliter water in test tube. Your fresh solution of sodium hydroxide is now ready. Now put a piece of aluminium foil in it. You will see that reaction has started. Now take a burning matchstick near the mouth of test tube. You will see that again a popping sound produces here. It means the gas produced here is hydrogen gas. Because occurring of popping sound when a gas reacts with burning matchstick is a characteristic feature of hydrogen gas. Students, now let's see how metals reacts with solution of other metal salts. For this, let's perform an activity. Take a clean wire of copper and iron nail. Put the copper wire in a solution of iron sulfate and the iron nail in the solution of copper sulfate taken in test tube. Record your observations after 20 minutes. In which test tube did you find that the reaction has occurred? We find that the test tube which has copper wire and iron sulfate do not possess any change, but the reaction takes place in the test tube containing iron nail in copper sulfate solution. Here the color changes from blue to green. Why this happens? Because iron reacts with copper sulfate solution and displaces copper from copper sulfate solution and form iron sulfate with green color. This reaction is called displacement reaction. In this reaction, a more reactive metal displaces less reactive metal from its salt solution. Now, dear students, let's understand about activity series. It is a series of metals which is used to study the comparative reactivity of metals. It may be defined as the arrangement of different metals in vertical column in order of decreasing reactivity of the metals. The most reactive metal, potassium, is placed at top of the reactivity series, whereas the least reactive metal, gold, has been placed at the bottom of the series. The metals in reactivity series are arranged in this way: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. Now, let's see how metal and non-metals react with each other. Students, as we all know that every element wants to complete 8 electrons, or we can say they want to complete their octet in the outermost shell, which is called valence shell, in order to acquire nearest noble gas electronic configuration. Due to this condition, in outermost shell, noble gases are least reactive because they have 8 electrons in their outermost shell. Therefore, we explain the reactivity of elements depends upon its valency or number of valence electrons. Let's see electronic configuration of some noble gases, some metals and non-metals. The outermost shell of atoms of metals have 1, 2, 3 electrons. 1, 2 or 3 electrons, which they easily lose to form positive ions or cations. Whereas the outermost shell of atoms of non-metals has 4 to 7 electrons. So, they take electrons from other atoms and form negative ions or anions. So, metals have positive charge because they lose electrons, and non-metals have negative charge because they gain electrons from other atoms. The compound formed by the transfer of electrons from a metal to a non-metal are known as electrovalent compounds. For example, sodium chloride and magnesium chloride. Let's see some properties of ionic compounds. First of all, physical nature. Because of strong force of attraction between the positive and negative ions, ionic compounds are solid and are somewhat hard. They are generally brittle and break into pieces when pressure is applied. Second property is melting and boiling point. Ionic compounds have high melting and boiling points. This is because a considerable amount of energy is required to break the strong interionic attraction. Third property is solubility. Ionic compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Fourth property is conduction of electricity. The conduction of electricity through a solution involves the movement of charged particles called ions. Solution of ionic compound in water contains ions which move to the opposite electrodes when electricity is passed through the solution, and it compounds in solid state do not conduct electricity because movement of ions in the solid is not possible due to their rigid structure. But ionic compounds conduct electricity in the molten state. Extraction of metals. The elements or compounds of metals which are found naturally in the earth crust are called minerals. At some places, minerals contain a very high percentage of particular metal, and these metals can be profitably extracted from them. These minerals are called ores. The process of extracting the metals from their ore is called extraction of metals. Extraction of metals is done on the basis of their reactivity. First of all, we are going to discuss metals of low reactivity. These metals are present at the bottom of the activity series. For example, mercury and gold. These metals can be obtained by heating their oxide ore. For example, cinnabar is an ore of mercury. Its formula is Hgs. When it is heated in air, it is first converted into mercuric oxide, that is HgO, and on further heating, it is then reduced to mercury. Now, metals of medium reactivity. The example of these are iron, zinc, lead, and copper. These are usually present as sulfide or carbonate ores in nature. The sulfide ore are converted into oxides by heating strongly in the presence of excess of air. This process is known as roasting, whereas the carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. After that, these metal oxides are reduced to their corresponding metals by using suitable reducing agents. For example, when zinc oxide is heated with carbon, it is reduced to metallic
Children, we have
zinc.
learnt corrosion in chapter number 1.
ZnO
We
plus
all know
C,
about it.
it gives
As you all have
zinc
seen,
Zn
silver articles,
plus
when they
CO.
expose to air, after some time, they
Third,
get a black
metals
coating.
of high
That black
reactivity.
coating comes due to the
These
reaction of
metals
sulfur gas
are
present in the
present
atmosphere,
at the top
and it forms
of the
a sulfur
reactivity series.
sulfide coating
For
of
example,
black color. Due
sodium,
to that, silver
potassium,
articles become
calcium.
black. Just
These
like that,
metals
you
are
must have seen
obtained by
copper vessels.
electrolytic reduction. For example, sodium are obtained by the electrolysis of their molten chlorides. In this reaction, the metals are deposited at the cathode, that is, the negatively charged electrode, whereas the chlorine gas is liberated at the anode, means at the negatively charged electrode. Now let's discuss about refining of metals. To remove the impurities from the metals produced by various reduction processes to obtain pure metals, the most widely used method is electrolytic refining. Many metals such as copper, zinc, nickel, silver, gold, etc. are refined electrolytically. In this process, the impure metal is made the anode, means the positive electrode, and a thin strip of pure metal is made the cathode, means the negative electrode. A solution of the metal salt is used an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte and equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. 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 students, here we come to an end with this chapter, that is metals and non-metals. I hope you all have understood it nicely. So students, be safe, be at your homes and be happy. Thank you.